Did you? You should be okay. SYNCC conference. Maybe you've heard about this conference. I highly recommend. It's the fetal and fetal infant toddler imaging. Anyways, here I am. My name is Cécile. I did my PhD, now it's been a while, unfortunately time flies. In developmental fNIRS, I studied language acquisition, but then I mean, my most cited paper is a NIRx method paper. So I hope it helps. The point is, please ask me any questions, because I know it's difficult. I have never done hyperscanning myself, so I'm less experienced in that regard, but I've tested so many babies. I think at the end of my PhD I had tested between 500 and 600 babies, so I know the pain, which is also why then I did a postdoc with birds. I had enough of babies. But it's different. The difference is that you anesthetize them and you open the skull, which is a different type of constraint. Anyways, I would like to first ask, so everyone is doing fNIRS research? Or please raise your hand for fNIRS. Okay, EG? Behavior? Or physiology like heartbeat, eye tracking, yeah. All right. Any other methods that I have not mentioned? Ah, you do fMRI, fantastic. Also hyperscanning or?
No, single person.
Yeah, enough.
It's enough.
Okay. Is that why you turned to fNIRS, because you wanted to do hyperscanning?
Yeah, it's more like naturalistic environment and so
Yeah.
cheaper.
Yeah, of course. Yeah, okay. Thank you very much. And in terms of, okay, the next thing I would like to do, because as you can see, my talk is going to be rather practical. I'm not a talk person. I like to chat with you, which is why when I was doing research, I would always go to conferences with posters, because I like to chat with people. So I would like to do the other way around. Could you please go like this and give me one sentence? What do you do? And no, I would say, what is your current biggest problem in your research? One sentence. So because there are a lot of people, so we don't spend half an hour doing this.
So for me, it would be data analysis.
Data analysis. What especially? What is the issue? Where are you stuck?
In general, I don't have much experience with data analysis.
So you don't know how to approach the data set, or?
I know how to clean the data from EEG, but actually, no.
And you come from EEG. So you basically don't know how to analyze the data in terms of the global step strategy, the global steps, the very general pipeline. Okay, thank you. If you can say your name also, that would be nice. Cécile, this I know.
My name is Chen. My biggest problem right now is neural synchrony in EEG hyperscanning other diets.
Why? More specifically, what is the issue, the technical issue?
The technical issue per se is that there is no, like it appears that I feel like WTC of this information, so very like the go-to method.
Yeah.
To calculate it in EEG, it's not very clear. If it's face, it's amplitude, what is the important thing?
In fNIRS or in EEG?
In EEG.
Okay. And do you do fNIRS?
Yes.
And, oh, sorry, I'm lost.
I do both.
Yeah.
I know how to do it in FNIRS. In EEG, I'm figuring it out.
Ah, but you know how to do in fNIRS?
Yes.
Fantastic. Okay. Okay, I see. And with fNIRS, it's all right?
I got it. Yes.
But I mean, okay, so right now your problem is EEG, not fNIRS. Oh, okay, fantastic. Thank you. I mean, not fantastic, but you see what I mean. Thank you. Daniela, I know you. Yes. Hi.
I'm Saida
What method do you use again? You said, I think I remember heartbeat or eye tracking.
In Synchrony, code where the people look, whether they're looking at the other or
Okay.
at the person, and what is sometimes a problem that one needs to interpret.
Yeah.
What exactly they're intending to do. But,
Okay. Is there a question that I can help you with today? Okay. Thank you.
Hi, I'm Laura. Well, actually, I haven't started the research, but at the end of master, I did the PG, and I would say that it was mainly data analysis, and it was quite a struggle for me to understand how to doing this. So, yeah, I would say that how to properly process and the data.
Okay. Okay. And you don't do fNIRS, as I understand. Okay. Do you want to do? Is it a plan or?
That's the plan. Yeah.
Okay, fantastic.
I'm starting my PhD in November, so I'm doing research yet. I'm interested in fNIRS and prescribing. I don't have much experience with it, so I want to learn as much as possible.
I'm Verena, I'm a SYNCC student, and it's the fNIRS that I'm doing at the Heidelberg.
Okay.
Hi, I'm Alicia. I'm a medical doctor in Milan. So we don't use NIRs because I thought about with Dalila in Warsaw, and I was pretty interested in it. But since it's not like diagnosable, we can actually use it in our clinical practice.
Yeah.
So we do just part of the score and heart rate variability.
Which is indeed something you can extract from the NIRS signal. The heart rate variability you can extract indeed from the NIRS signal, but I guess you have a pulse oximetry device.
Yeah.
Exactly. Okay.
Hi, I'm Carlos, and I'm a PhD student, and I just started using fNIRS. Actually, I used also during my master's thesis, and now I'm starting using for the PhD program. I think the most challenging part would be the data analysis as well. Maybe like detecting the oxymoglobin, signals, and compute the Synchrony between the two participants.
And right now, are you collecting data?
Yeah, I'm starting.
Okay. Is everything all right?
So, I can see the data collected.
Okay. Is there something regarding the data collection that you would like to improve or?
Maybe it's a bit early to define something like that. Maybe when I collect more data to see how the signal will be.
I mean, very practically, when you're in the booth with the participant. When you're in the booth with the participant. Is it okay?
Yeah.
Like putting the stuff on the, managing the parent, putting the cap on the head, turning on the device, all those million things you have to do in the lab. And
That's fine. We're using it with young adults. So it's, no, that's fine. We use 2 caps and they help us.
Okay. Good luck then.
I am Alessandro. I worked with the NIRs in 2000 at the Child Heidelberg. And I would say my main research focus now is in defining and quantifying different methods to process Synchrony, comparing metrics and
Okay. So you're a method guy.
yeah, I work with people that already
Okay.
Hi, I'm Ante, and I'm just interested in learning more about fNIRs in EEG. I haven't worked with those before. All I can consider
Okay, what type of variable did you analyze?
So we looked at all the different streams of communication, so gaze, vocal affect, head orientation, touch, and we coded that second by second. And I'm currently doing a project evaluating a clinical interview. So we take clients and patients and put them in our microanalyzer.
Okay, so it's more like natural interaction that you code offline, right? And you don't do neuroimaging at all?
I was not instructed in it, that's why I'm here to learn it.
Okay, fantastic.
Hi, I'm Katrina, and I just finished my PhD, which didn't include any fNIRs, but I'm interested to know more about it and other methods. It's very new to me.
What do you do now?
What am I doing now? I'm kind of looking for my next step, but my research is kind of around more behavioural and biological things regards to like stress responses and interaction.
And still with several participants interacting, correct?
Yeah, so
Okay.
mother and child and father and child.
Okay, always mother-child. Okay. I mean, I know it's more or less the theme, but you know, I prefer to ask because people come for various reasons. Okay, and so you have a plan to include neuroimaging, or?
Maybe, I want to sort of understand more about it and its methods and how it can be utilised. So, obviously, just all the details about it.
Okay, and just out of curiosity, what's the theoretical hypothesis you're looking at?
It's still developing. Still thinking about it at the moment.
Okay, maybe. We talk later because I understand the methods you use, but I cannot see why you use these methods.
Oh, so that was my previous sort of research. What I did was biological interactions now. So the next bit of research, basically.
Okay. Sorry, I didn't see you. Alessandro was hiding you. It's like when you're at the movie, right? And you have this big guy sitting in front of you. You cannot see the movie.
I'm Elias. I'm in the middle of my master's in psychology at the Institute, and my master thesis actually focuses on resting state, functional fMRI, and in mothers with impaired bonding. So
Bonding. Yeah.
It's more attachment.
Yeah.
But I've actually never done fNIRs. I mean, I attended a workshop at the CNSR, but I've actually never done it myself, so I'm interested to get to know how.
Okay. And do you record the infant as well, or only the mother?
Only the mother.
Only the mother. Okay. And how long after how old is the baby when you record the mother?
I think 2 years.
2 years. Okay.
Hi, I'm Berit, and I just started my PhD, so I'm still figuring out what exactly I want to do, but I will be mainly using EEG as a method, but other people in my lab are using fNIRS, so I thought it would be cool to understand this method better and learn about it.
I'm Hannah. I'm also a PhD student doing my bachelor thesis in EEG, and I'm also maybe overwhelmed by the data analysis of EEG.
You do only EEG. You do only EEG.
Yeah, like EEG and ERPs.
Okay.
Hi, I'm Janek, and I'm an intern student. I'm just starting, so I can get with the platform for more experienced researchers from my lab.
Do you know the project that you will help with already?
Yeah.
So what is the project about? Do do you have a vague idea of what you, or a precise idea?
Already collecting data. We're doing EEG, dual EEG, while the participants watch films, short
Okay.
clips of films, and there's a Sakura at the start and free conversation while they have the EEG caps or fNIRs.
Okay. Okay.
I'm Maciek, I'm a master's student, also doing the same project, and I'm mainly involved in the eye tracking part of the study.
Okay.
But I attended these workshops and I'm just waiting to learn.
Okay, so you're an eye tracking person. Fantastic.
Thank you.
Hello.
Yes, I'm a research assistant at the University of Copenhagen, and the biggest issue in my work right now is noise in infant fNIRS.
Okay. What kind of noise?
Different. So we have hyperscanning in a frequent paradigm, and the resting state where the infants sit on their parent's lap
Okay.
for like 5 minutes.
Yeah.
But they move a lot during all this.
Okay, so it's motion artifacts. Okay. Okay, this we can talk today.
I'm Maciek and I'm a professor, so I'm mostly lack of time. I was mostly EG.
Okay, so co-recording or separately?
Well, no, just a separate, different, no hyperscanning. Try it before.
But I mean, you have the EG and the fNIRS on the same cap, or is it two separate experiments?
I would just try to have new data once, but since that time, new.
Okay. Okay. Hello.
Hello, I'm Eka. I'm the project manager of SYNCC-IN project. Nobody said that.
And you have a beautiful cat, so this I remember as well.
And yes, we are starting the new studies now. I personally don't know what we have if we have any technical problems because we have some more intelligent people to do the technical problems.
It doesn't, unfortunately, you have brilliant people who run into my perspective is that very intelligent people create problems because they find they you know I'm doing mostly support at fNIRS, and 80% of my calls with customers is telling customers that they don't have a problem and it's not as like they made their own life difficult themselves. So I would say, let's simplify everything. My job is to simplify and make people understand that things are more simple than what they think. And I think this is the problem of very intelligent people. They want to think about everything, but at some point, it has to be simple.
I don't know if we have solved. I don't think we have any ethics problems so far. We have problems with recruitment, especially preteens right now.
Well, how old are they?
Preschoolers, yeah, between 3 and 5.
Okay.
And we are aiming to have a group of typical development children, autistic children, and preteens, and so
Okay.
preteens are the most difficult.
Mm-hmm.
And we were thinking that it's going to be the autistic group for the most difficult, but it happens. So yeah. Okay, I got maybe we know more about the ethics problems we have. We have any problems? Yeah, that's why API is something project, and I think our problem, or maybe not a problem, but something we'll have to deal with, it will be how to merge data, because we have news data, interpret data, heart rate data, behavioral data, so somehow we need to make psychological sense out of
them.
Mm-hmm.
And we're also doing the same with EG and FNIRs separately. But at some point we may want to maybe see, so of course there are different measures, so they focus on a little bit different things in brain, so quick response, slow response, so how to understand what's happening with FNIRs and EG, how to compare those data. Maybe it might be something that will be a challenge.
There is an entire literature on this. And it's yeah, I mean we can talk about it, but it's the field about hemodynamic response, and of course then it touches you have beautiful animal paper, because you know when you can open the skull and put an electrode inside the brain and put the microscope to see the vessel dilating, it helps to understand how the hemodynamic response arises from neural activity. So there is an entire field about this, but we can, I think you're more in a practical way in the context of, in a psychological context, but we can talk about it for sure.
I'm working on multimodal integration of various like modalities, like during interaction, like FNIRs understanding data, facial expression, word they speak, and put everything together. Difficulty is like interpretation and writing.
Okay. You're a PhD student, postdoc? Okay. So yeah, I guess you're reaching more or less the end where you're writing and wrapping things together.
Hi, I'm Joanna. I'm also a single manager and a researcher, and my main problem with the NIRs is that now I need to start collecting the data with children with cochlear and measured synchrony and first scanning between them and their mothers. Yeah, so basically I need to figure out how to make it possible to compare it to typical developing children. So,
How old are they?
the same as saying.
Okay. Yeah, preschoolers. Okay. Okay. Just who is studying infants, so 0 to 1 year? Okay. Who is studying toddlers? And the rest of the people is adult, I guess, or older children? Preschoolers?
Adults, mothers.
Okay. 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 Fantastic. Last but not least.
All I can say is we have like 20 years of research in EEG with infants and older kids, but and I really like the time sensitivity of EEG. And fNIRs is new to me. We have Jen in our team who brings it with her, and we have SYNC-IN, our project, where I think that I'm wondering, Synchrony has a lot to do with time-sensitive responses to each other, and I'm not sure how far fNIRs will get us there, but I'm curious.
Yes, fNIRs answers completely different questions. fNIRs will tell you about the brain maps. So more like is it the same regions in the two people and so on, but I think it's very complementary.
Yeah, I know, but it will be challenging to bring it together because Synchrony has something to do with time.
Yeah.
So how are we going to manage that? I'm curious.
Do you want to put the EEG and fNIRs on the same cap, or do you want to do two separate experiments?
We try, but it's very difficult, so maybe we get away from it already. I'm not sure yet.
What was the difficulty?
I think you piloted it.
Yeah, it's more like a practicality issue.
Yeah.
Because I think the amount of electrodes that we use, plus the electrodes, plus the amplifier of the EEG system, on the cap of a baby that is 12 to 14 months old, is not tolerated. That's just
Okay. Okay. How many electrodes and how many optodes do you have?
So 12 electrodes and 16 optodes.
Okay.
Plus amplifier.
Because the amplifier is on the head. Yeah.
Yeah, because I was thinking it's not so bad, it's more or less what I was doing.
That's what we thought too. And then I tried it.
But I didn't have the amplifier myself, so. Yeah.
And the age, that was, it's just a nightmare.
Yeah.
They want to move.
No, I know. This is, I went to bird. You anesthetize them. There you go. No, it's true. Okay, so I'm going to, as best as possible, adapt my talk to what you just said. Please feel free, we're a small group, interrupt, ask question. It's a bunch of slides, and the goal is to do something that is useful for you. So I will maybe skip some stuff, or we can spend more time if you have more questions on other slides. So, what are we doing here? We are looking at what happens, how do we go from the left to the right? How do we go from someone who, like a shrimp in a crib who is like this, to people like us? What happens in the body? How do we reach this thing called adulthood, if there is any? We have different things to do this, to try to understand what's going on during these first years of life or the lifelong perspective. Here is just to, so we can do EEG, we can do fMRI, mostly behavioral fNIRS. And this makes me very happy because we can see that there is an exponential growth of publications. This is especially for fNIRS, but of course it's always very nice to see that more and more people are entering the cult of cognitive developmental neuroscience. So this is where we are. I think this is also why you are here today. Let's keep growing. So, of course, I will focus on fNIRS because I work for an fNIRS manufacturer. I can, of course, have my developmental neuroscientist insight for the rest of the methods, but I will focus on fNIRS. So, why do we like fNIRS? I think fNIRS is a very good method for developmental population. And why? Because it's resistant to motion. So some of you have mentioned the motion artifacts. Let's talk about this. There are some approaches to deal with this, so we can talk about this. Contrary to fMRI, it's silent. So if you are working with babies, it's super convenient. You don't need to place them the headphones. They don't cry because of the noise. So it's nice. And this is directly reflected in the attrition rate that is rather low compared to other methods. So it's a meta-analysis from 2003, where they found that for fNIRS, it's about 34% of participants that they reject for the final data set, compared to 47% for EEG. So EEG, it's almost like you're going to test twice the number of participants that you need for the data analysis. Which, when we know how difficult it is to test a baby, it hurts. Okay, some of you have mentioned naturalistic setting, coding behavior during interaction. I think the natural aspect of fNIRS, that is just a cap and not an entire scanner, is also very appealing for people like you who study interaction between people in social interaction. And of course, the baby can be tested either in the car seat or in the parent's lap, which is very convenient. And so in the end, fNIRS is about how we go from the left to the right. So how we go from electrical signals to beautiful brain maps of activation, seeing which parts of the brain are activated when the participants are doing the task, or in our case, interacting. Okay, so I'm going to be completely honest with you, and I think this is also a topic that we can touch upon during the coffee break. I am not a fan of co-recording EEG and fNIRS. I think it's better to do two separate experiments, and this is because the constraints, like the technical constraints, you mentioned that EEG is a fast temporally resolution technique. fNIRS is a slow but spatially precise. So that means that the way you design the experiments are completely different. It is feasible to have both on the same cap. If you do ERP, I think it's better, but if you do oscillation or if you do microstates from the EEG, I mean, you are the researcher, so in the end you are the person who knows, but I personally think that it's better to have two separate experiments. Yes. Exactly. Something that is also, so in theory, this is feasible, and this is also the benefit of the cap is that you can put different things, but then comes the problem of experimental design. So it's, I would say, a very specific thing. Good thing about fNIRS is that because it's a small cap, you can do very easily longitudinal studies. Who is doing longitudinal studies here? Okay. I like the fact that the PIs are raising their hands and the students are like, no. Not on my dead body. Okay. So yeah, so the cap is the same, the system is the same. Here you see there are two siblings of different ages, but they wear the same system, same montage. So if you want to compare ages, if you want, I think you also see this during mother-infant interaction, right? The mother and the infant can wear the same cap, and it makes the recording easy, and it makes the transfer, like the comparison between the two activities and the synchrony, it makes your life easier. Which is nice. Okay, so these are for the generalities about fNIRS. I would like to talk about montage design and setup. So this part is going to be extremely down to earth and practical. We're going to talk about how to place the optodes on the cap because it looks simple, but it makes 80% of the data quality. It makes a lot. So something to consider, and surprisingly people don't think about it, is that the definition of a child is that it grows. So when someone says, I'm studying infants, for me it doesn't mean much. Because are you studying newborns? Are you studying 1-year-old? You know, it has nothing, the two ages have nothing to do. So we know that at birth, the total brain size is already 35% of adult size. But you see that at the end of the first year, it's already 73%. So that gives you an idea of how much it grew in just 1 year. Just the first year of life, the brain is almost at its adult size. The growth is steady, but it's inhomogeneous, so the frontal lobe develops the last, and the visual cortex is the first one to develop. So you have a posterior-anterior gradient of maturation, which is also interesting to know if you know neuroimaging, because you might have data that you find weird, in the sense that if you measure whole head, you would have more typical response on the occipital area, and you would have more weirdly shaped response on the front. And then often people come to us and say, my data is weird, I don't understand why I have bad data quality. And my answer is, your data is fine, you're recording a baby with an immature brain. So the data is, the shape of the data is going to change. The nature itself of the data is going to change. Of course, then there are plenty of papers that I can send you because it's more and more studied. And the conference at the beginning of the week, there were a bunch of discussions about this. So there is something to do. But let us not consider this as noise. It's development, not noise. Yes, oh yeah. The last point, very important for fNIRS, is that you know, very young babies, they have the fontanelles, right? So they have the holes on the midline of the skull. This is the most prominent sign that the skull is changing. So at birth, they almost have no skull. It's more like a sheet of silk paper. And as the baby grows, it's going to be calcified, rigidified, but also more thick, and which means that, again, the signal is going to change, because whether it is EEG, then the EEG is going to be less diffused in younger infants. It's going to go more straight to the electrodes because you don't have the diffusive effect of the skull in very young babies because the skull is not there yet. And as the baby grows, the skull is going to increase, so the diffusion of the EEG signal is also going to increase. And for fNIRS, it matters because the distance between the cortex and the scalp is going to increase. This also changes how the light diffuses in the head, so this also changes the signal quality. Again, your data might be problematic, but in most cases, you're just recording a developing brain. So let us not forget that there is anatomy, and anatomy changes a lot during the first year of life. I think if you're studying more toddlers, you're a bit more fine because, as you know, as I said at the beginning, most of the growth is going to happen during the first year of life. But still, I think this, especially if you record a mother and a child, you might find that despite the fact that during the experiment they had the same system, they saw the same experiment, they have the same montage, everything looked good, the signal might look different between the infant and the mother. Don't worry, it's because you have an adult and you have a child. So it's because of the biology of development. Okay, this is more for infant people. The conclusion of all that I just said is that you might want to, you should adjust the channel distance for fNIRS. 3 centimeters is recommended for adults. Please don't record at 3 centimeters for infants. It's way too long, and this is because the head is smaller. So imagine we have an adult head like this, and let's say like this. If the light enters here and reaches the cortex and go there at 3 centimeters, it's fine, right? Now, if the head is this size, 3 centimeters, you see relatively how big this is. I haven't moved my right hand. I just did this from this. So you see now, if I use this distance, the light is going to propagate like I forgot the name. Well, the curvature of the light path, you're almost at the center of the sphere, which is not, unless you're interested in the thalamus, but if you're interested in the cortex, please reduce the channel distance. Also because you see the head the scalp is much thinner, so the light propagates much easier. This is an extreme case of neonates. You see that it's exactly what I was mimicking with my hands. With 3 centimeters, you reach very deep in the brain. That being said, this is a neonatal head model for older children. There is no research. I spent the last few days of planting the seed in people's brain that they have to do this study of photon propagation simulation in older infants, and then people said exactly as you said, yeah, but I don't have time. I just say, hire more students, it's not my problem. As a manufacturer, I need to know what I should tell to my customers. The good alternative for this is the 1020 system. I would say keep using the 1020 system because it's a proportional, not absolute system. So 1020 refers to 10 and 20% of the inion to nasien or ear to ear distance. So because it's a percentage, when the head gets smaller, the distances are also going to be smaller. I can send you the slides later if you like. Yes, and the anatomical positions, the anatomical correspondence between the 10-20 position on the scalp and the cortical coordinates is very well known. There are plenty of publications about this. So I would say go for the 10-20 system. Has anyone ever used digitization systems like the Polymus? Wow, brave people. Sorry? Yeah, right, because the baby has to be completely still.
Which is not possible. And then you want to be in a metal-free room. It's like, we don't have a metal-free room in our
Yeah. Yeah, I mean, I have stuff in my teeth, right?
glasses.
Yeah, glasses, I mean, yeah. I mean, at least the glasses I can remove, but I cannot remove my teeth. Or I would say no. Okay, have you used photogrammetry? Okay, what is your thought about this?
I mean, in theory, you think it would be better. Can't get it to
Which system was it?
try to swarm it.
Okay, and it didn't work. I don't know. I've never used it myself, so I'm very curious about people's experience. Okay. Anyone else? No. Okay. Okay. This is just. It's honestly, it's not so important. The 10-20, the head, the shape of the head is changing mostly in the first 2 years of life, and of course, the younger the infant, the more far away it is from the adult shape, and because the shape of the head is different, the 10-20 position will land on different parts of the brain, right? Because then the skull is changing shape, so. But the brain is still around, so imagine that you have something like this. And so you see that if I have a 10-20 position here, for example, and my brain is here, let's say at the beginning of life and of the first year of life, it's it's lower on the temporal lobes. And then as the skull gets its adult shape, it's going to move up and be more towards very in the middle of the temporal lobes. So this is why, but fortunately it's mostly for the lower positions, so the occipital and temporal positions might change. So please use an atlas. The point is, please use an atlas that corresponds to your participant's age. I know it's difficult because you do fMRI, you know that the quality of the atlas is not going to be very good. But if you can, I think the North Carolina atlas has plenty of ages, right? Never used it myself, but I think the North Carolina atlas has plenty of. This is the one that I've heard people use. And this is a great paper. It's a friend, so of course I recommend her papers. No, but it's a great paper. All the links you can click on them. These are links that you can click on and takes you to the paper. So I will send you all the slides and you will have everything. Okay, now going to the booth. I think this is valid for all methods. You want to keep the cables away from the child as much as possible. This is why having the amplifier on the head is so appealing at first, because you think that, everything is on the back of the head, so the infant is not going to do like this. But exactly, and then when you start testing, you realize that it's about the weight, right? That it pulls the cap to the back, no?
For the EEG, it's the accelerometer that's in the back that helps with the motion artifact. It's a wireless system.
Yeah.
So that's why. We didn't want to put it there in the first place, but because it's the brain axis, so it's supposed to go there.
I don't think I know this. Who is the manufacturer? Is it Brain Product? Is it the Brain Products? I didn't know they had a system with the amplifier on the cap. Okay, that's interesting. Yeah. And it has to be because the accelerometer is there. And which NIRs system do you have? So you have the accelerometer from the NIRs Pro 2.
It's not in the It's complicated.
Okay, because my first thought would be, yeah, but what about using the accelerometer from the NIRs Pro 2 so you can leave the EEG amplifier on the table?
Yeah, but it doesn't have the EEG, because it doesn't have the same sampling rate, like it's not.
Ah, yes, true. Okay, yeah, yeah, exactly. I see. Yep. Okay. Okay. So we do offer a fiber arm. It's not specific for fNIRS. Oh, you can use it with anything. So, but I highly recommend passing the cables there, and so the arm can hang above the baby's head, exactly like on the picture. And so the baby doesn't touch the cables. It also alleviates the weight of the cap, so it prevents the cap from sliding to the back, which is very useful because fNIRS is a spatial localization technique, so you don't want the region you record to change across the experiment, right? You don't want that at the beginning of the experiment you record one region, at the end you record another one.
Sorry, is there any reason that baby, because we tried to use this kind of arm and then we figured out that if the baby, let's say, stands up or move or try to move, it can like pull the cable too much. Because we have quite a visual system, so we don't have the whole box, we have like small thing attached to straps. So like they can move, they can even walk. So our worry was that with the arm, if they try to, let's say, stand up, move around, they will hear the cables.
But I would say, how is your experiment? Is it a moving setup?
No, they are supposed to sit, but and watch the movies.
Okay.
These are preschoolers.
Yeah. Yeah. Okay. And where is the system right now? On the back of the child, or?
So no, actually, like the amplifier is in front, so we attach it to the straps in the front.
Okay.
So
you have straps. Okay.
Yeah, straps, and the weight of it is like half a kilo.
Yeah, I've seen the system. Yes.
The cables, I mean, even if they are on an arm, they go down, so the weight is still there, and then they go up. So.
But I must say, in your case, I don't think you would need an arm, because if they have the octodes on the head and the system here, it's fine, no? I mean, they want to add because you're afraid that they're going to grab the cables here?
No, I am like commenting on the weight of the cables and the possibility.
For the weight.
Yeah, the cables, not the system itself. It's not heavy.
Do you find that the cap is moving during the experiment?
No, not really.
Then you don't have a problem. You see? I love saying this to people. No, I mean, life is complicated. One less problem is always nice. Yeah, okay, so I'm thinking, what should we do now, because we are very short in time? Yes?
What do you think about short distance channels on babies?
In theory or in practice? Exactly. I would love that we develop this, but we don't know the distance. We don't even know the channel distance for the regular channel. So for the long distance, we don't know. We could do something, but yeah, it's a more long-term strategy. Like, I don't think it's going to happen anytime soon. I don't think it's the company's strategy to develop this. So, remind me how old they are?
So we have this like big cases when 16 octodes waking up, 22,
But how old is the baby? Okay, no. Because 8 millimeters, I'm not sure you will reach the cortex, but you will probably go rather deep with the 8 millimeters. Yeah, 12 to 14. I'm thinking, what is the head size for this? It's like 46 something. Yeah. I still have good memory. When I was doing my PhD, I would see like kids in the trolley, and I would be like, 42 in the street, 38. Anyways, no, it's too long. 8 millimeters is too long. You're going to go deeper than just the superficial tissues, and I cannot guarantee that you will not reach the cortex, and the problem is that if you reach the cortex, you're going to be cortex minus cortex equals barely anything. So you're going to kill your signal. I mean, have you read the paper by Lauren Emerson about this, right? And you see like it kills her results. It kills her, but also she's using 1 centimeters, which is way too. Also, she has, I think it was 6 months old. Anyways, No. I mean, I have looked at it. There is an interesting paper to answer your question, and this is a good thing. I should include a slide about this. There is an interesting paper by Jessie Fu, the lady who is doing the default toolbox. She made a paper about scalp to cortex distance across, I think it goes from birth to 25 or 26 years old, so the entire development. And so you know that because the channel length is twice the distance, right? So you can see at your age what is the scalp to cortex distance, but I suspect it's going to be very close to 4 millimeters. So 8 millimeters would be probably too much. I would not recommend. Yes. Yeah, I know. I have the time here. Okay. I had a few slides about experimental design. There are 2 things that I want to tell you. The first thing is physiological consideration. So, I'm sorry, I got bitten by mosquitoes. I talked about anatomical changes during the first year of life. The physiology also changes. So you know that myelination is not done at birth, which means that during the first years of life, the neural transmission is going to get faster because of myelination, which means that the EEG will look different for sure. It also has an impact on the hemodynamic response. The vasculature is also not mature in very young infants. So the hemodynamic response is, some people say slower, some people say inverted. I published, this is the method paper that is more cited than my experimental papers. I don't have a definite answer for this. I had discussions about it at the conference with people. It depends on the age, it depends on the region because of this posterior to anterior developmental gradient. So this is also why, in terms of data analysis, I'm always very cautious when people want to do a GLM approach with the developmental data, because the GLM requires that you have a model for the HRF, and which we don't for the development. So I would say, I think now you have data-driven approaches for the GLM. I can send you papers again, but I would say be extremely careful and look at your data. you might find that the data is weird, and you might want to throw it out because you might think something went wrong during the experiment. It's not. It's just that kids are developing and the brain is changing. The physiology is not there, so the vessels are not as, the vessel compliance is not the same. The communication between neurons and vessels is also not completely mature. So just go and explore and trust the process, I would say. It might look weird, it is, and this is called a baby. So or a child. So don't worry too much about this, but just be very careful when you do GLM. Maybe you want to rather have a block average approach. Something very important that I want to tell you about is the baseline. Because in adult, it's quite simple. You put the fixation cross to people and you tell people that there is a black screen and there is a break in between blocks and they're supposed to just wait until the next block starts. I think you know that you cannot do this, right? If you present a blank screen to a child, they're going to be fussy, they're going to start shouting, you know, something has to happen. The question is then, what is this something? What do we do instead of presenting a black screen and a fixation cross? I love this paper very much. It's also a GLM, it compares many GLM approaches on developmental data. Some of them modeling the HRF, which I think is a very powerful approach. They average all the blocks, and they take the average as the canonical response as the HRF model for the GLM analysis, which I think is a very powerful approach. They also test MVPA, so the classifier, data-driven approach, which is interesting. Going back to, so I highly recommend reading this paper. Going back to the experimental design and the baseline, I think this applies to all methods. What is a good baseline period? Do you present unrelated conditions? So this paper is about face perception, so they presented vegetables, because vegetables are not faces, and still it's fun, so the infant is it's colorful, so the child is going to look at it. The lab where I did my PhD, they were presenting the Windows Savior, you know, the screensaver, you know, the bubbles, the Windows bubbles, because again, it moves, it's colorful, the baby likes it. So for a few seconds, they would see the bubbles, and then the next trial comes in. I don't have any definitive answer to this. My definitive answer is please pilot. Don't call me when you have collected 60 babies, it's too late. You might receive an email from me telling you that unfortunately your data goes to the trash. And I don't like to write this email to people. Please don't do this to me. So call me in advance. I'm very happy to discuss your experimental design over a call with you. So when you're about to start your experiment and you want to, before you test the first participant, you can call us, and I'm very happy to review your experiments with you, and then you test, let's say, 2-3 participants, you come back to me, we discuss again, so we can make sure that the experiment is good to go. And then whatever the results, maybe it works, maybe it doesn't work, but at least the experiment was well designed. I need to stop here. I could talk about data analysis recommendations, but I think I don't have time. Any question? You've been very quiet. I know. I'm not a morning person, but I have cats, and you know, at the hotel I didn't have my cats waking me up at 5 a.m., so I was happy.